Welcome back, dear students. So today we are going to learn the ultimate and very important topic from determinants, that is the solution of simultaneous linear equations. Okay, now you have already learned how to solve simultaneous equations in two variables. Now what is the meaning of simultaneous equations? For that I am going to take one simple example. Let me see. 2x plus 3y is equals to 6. 3x plus 2y is equals to 6. Okay, so this is a simple example of simultaneous equation in two variables, right? Okay, now let me take simultaneous equation is three variables. So three variables, you can put x, y and z. Okay, so let's say x plus y plus z is equals to 3. Okay, 2x minus y plus z is equals to minus 1. X minus 3y plus 2z equals to 8. Okay, now see here, this is simultaneous equation in two variables, and the variables out here are x and y, whereas the variables in this particular equation are x, y and z, isn't it? So in determinants, we will be able to solve these two equations. Okay, and that particular rule has been given a special name, and that name is known as Cramer's rule. Okay, so it is called Cramer's rule. Now, as per Cramer's rule, what you need to do is, see here very carefully, all these coefficients are there, right? Okay, so all these coefficients, that is 2, 3. So the coefficients of first matrix is written, and so if the quotient of first equation is written as the first row of the matrix, that is 2 and 3. Okay, and the second coefficients of second equations becomes my second row, that is 3 and 2 comes in my second equation. Now the variables, the variables out here are x and y, so the x and y are written in this format. Okay, is equal to, now whatever numbers are here, they will be written in this way. See here very carefully out here. Okay, now if I ask you to represent this equation in matrix way, what you need to do is, first I told you, you have to write down the matrix. Okay, so here it's going to be 3 cross 3 because there are 3 variables, right? Okay, so what is the quotient of x here? It is 1, so this one will come here. Quotient of y is 1, will come in the second element. Quotient of z is also 1, will come in the third. Okay, now here the quotient of x is 2, the quotient of y is minus 1, and the quotient of z is 1, and the quotient of x is 1 here, quotient of y is minus 3 out here, and the quotient of z is 2. I hope this thing is clear. Now what are the variables here? The variables are x, y and z, so they will be put in a column matrix, and the numbers we have in the right hand side will be written as column matrix in the right hand side. Okay, so we have 3, minus 1 and 8. Okay, now we call this as matrix A. Okay, so this is your matrix A. We call this as matrix X, which is unknown. Okay, so in this case this is my matrix X. Okay, and this becomes my matrix, you can call this as B. Okay, so this becomes your matrix B. So basically when you combine these two, what you see here is AX is equal to B, isn't it? Right? And here you need to find the value of what? You want to find the value of XY, XYZ, or in other words, you want to find the value of matrix X. So from here, see here carefully, from here you get the value of x to be equals to, if you take this, or rather if you multiply with A inverse from left. Okay, so A inverse into A becomes I, so I into x is x. Okay, so here you get A inverse B. Okay, so this gives you the solution of such linear equations. Now you might be wondering, where am I using the concept of matrices, determinants? Now recently you have learned how to find A inverse, that is inverse of matrix, using the formula A inverse is equals to 1 by determinant of A into adjoint of A, right? So using this we are going to find the inverse out here, put the inverse here and do the multiplication. See here, inverse is also a matrix, so matrix and matrix multiplication gives you the value of x, that is this particular matrix. So this is how we find the solution of a given linear equations using Cramer's rule. Okay, now here also you have got few conditions to remember, that is called first and foremost, let's understand what is the meaning of consistency. Okay, so consistency. Now when you solve the equation, when you solve the equations, you may have one or more solution, okay, or else you may not have any solution, that is you may say that you have no solution, right? So if there are one or more solutions of any given simultaneous equation, then you say that the given set of simultaneous equations are consistent. Okay, so they are said to be consistent if the solution has one or more solution. If it has no solution, then you say it is inconsistent. Okay, so these are the two things that you need to remember. Now next is criterion of consistency. You need to remember this. Okay, so criterion of consistency. Now first and foremost, see here very carefully. So there are three criterion. Okay, so 1, 2 and 3. So let's understand one thing at a time. Now all of you know, for A inverse to exist, you should have A should not be equals to 0, right? Okay, for Ax plus B, Ax equals to B, for this equation to have solution, okay, so you need to have determinant of A not equals to 0. Okay, now if first condition says if determinant of A is not equals to 0, okay, then we say the given system of equations is consistent and has unique solution. Okay, and has unique solution, and the solution is given by x equals to A inverse B, right? So this is my first criterion for consistency. Now in the next case, if determinant is not equals to 0, and this time I'll put one more condition, and that condition is adjoint of A into B is equals to a 0 matrix. Okay, if these two happens, then we say that system is consistent. Still it's consistent, but see, when the system is consistent, there are two cases. One is there is only one solution. One solution means unique solution, okay, or you may have more solution. You have not said that you may have more solution out here. You are saying that just consistent here, isn't it? Here also you are saying consistent, but this time you may have more solution. Okay, and as I will not say more solution, I will say infinitely many solutions. That's what I'll say here. Okay, so if these two happens, then also system is consistent, but it has not one solution only, but it has infinitely many solutions. Okay, now again, if determinant of A is 0, and this time if adjoint of A into B is not 0 matrix, then we say system of given linear equation is inconsistent. Okay, so that's what you need to remember. Okay, so I hope this much is clear to you. Now, if this much is clear, let's begin with the sums on simultaneous linear equations. Now let's make use of whatever you have learnt just now, that is the criterion of consistency in solving such problems. Now question says, use matrix method to examine the following system of equations for consistency or inconsistency. Okay, now first and foremost, you know the the three conditions for criterion of consistency are given to you. Okay, now in all those cases, first and foremost, you have to check what happens to determinant of a, whether this is equal to 0 or not equals to 0. Okay, now let's see the first case here. Okay, so here we have a. Okay, so matrix A is the coefficients, remember, 4 minus 2, so we have 4 minus 2, 6 minus 3, so this is your matrix A. And what is matrix B? Because we have another condition also to be checked, that is adjoint of A into B. Okay, now whether this is equals to 0 matrix or not equals to 0 matrix, this is also one more condition that we need to check. So that's why let's write what is matrix B. So matrix B is 3 and 5. So this is my column matrix containing 3 and 5. Okay, now let's find what is determinant of A. Okay, so you see determinant of A will be equals to, so 4 into minus 3 is minus 12, minus, so 6 into minus 2 is minus 12, right? So if I add this, this will turn out to be 0. Okay, now if determinant of A is equals to 0, then from conditions of consistency we have to go to either 2 or 3. Okay, so because in criterion number 2 it is said, if determinant of A is equals to 0 and adjoint of A, that is this is a 0 matrix, then it is consistent and has infinitely many solutions. That's what my condition number 2 says, right? So first let's find what is adjoint of A. Okay, now for that you need to find cofactors, isn't it? What is adjoint of A? All of you know adjoint of A is the transpose containing these elements, right? Now all these, I'm sorry, 2 1 2 2, so all these are the cofactors, isn't it? So first let's find what is A11. Okay, so A11 is minus 1 to the power I plus j, that is 1 plus 1 into minor. Now what is minus of A11? Minor of A11 is minus 3, isn't it? Yes, so remove first row, first column, first row and first column, whatever element is left, that's my minor. Okay, so minus 1 to the power 2 is 1 only, so it becomes minus 3. So let's find A12. So minus 1 to the power 1 plus 2. So A12 means first row, second column. So the minor is 6, right? So it becomes 6 here. So it is minus 6. Okay, A13 minus 1, I'm sorry, A21. A21 is minus 1 to the power 2 plus 1. So remove second row and first column, second row and first column, you get minus 2 as the minor. So how much is this? This is equals to 2. Okay, now we have A22 minus 1 to the power 2 plus 2. So remove second row, second column, you are left with 4. So this is equals to exactly 4, isn't it? So your adjoint turns out to be, so let's see what is A11. A11 is minus 3, A21 is minus 6, A12 is minus 6, A21 is 2, and A22 is 4. So its transpose gives me adjoint, right? So its transpose turns out to be, okay, so let me write it here. So its transpose turns out to be minus 3, 2, minus 6, 4. Okay, so this is my adjoint of A. Okay, now we got our adjoint of A. Now we need to find this particular thing. So let's find. So we have adjoint of, therefore adjoint of A into B. So what is adjoint of A? It is minus 3, 2, minus 6, 4. What is B here? So I told you B is 3, 5, isn't it? So let's do the quick multiplication. So this is 2 cross 2, this is 2 cross 1. So again my answer is going to be 2 cross 1, right? So 2 into, remove it, so you get 2 cross 1. All right, so minus 3 into 3 is minus 9, plus 2 into 5 is 10. So similarly, minus 6 into 3 minus 18, plus 4 into, this is 20, right? So this is equal to, so 1, and this is 2. Now is this equal to 0 matrix? No, right? So this falls under which category? Condition number 2 or 3? It definitely falls under condition number 3, because it is not, this is not equals to a 0 matrix. So that's why we say, therefore the system is consistent or inconsistent. This is inconsistent. Okay, so the system is inconsistent. Now let's have a look at this particular question. Okay, now in this question also, okay, so we have a equals to, the coefficients are 6, 4, 9, 6. Okay, now from here if you find determinant of a, it will be equals to 0. Okay, 6 is a 36 minus 9 was a 36, so it will be equals to 0. Okay, now again we will find what is adjoint of a. So let's find what is adjoint of a. So let me quickly find it here. Okay, so a11. Okay, so remember a11 minus 1 to the power 1 plus 1, which is always positive. So what is a minor here? So minor will be, remove this, the minor will be this one. Okay, now a12 will be, it will be first and foremost negative, isn't it? Minus 1 to the power 3, so negative. Okay, now remove this, you get this, so this will be minus 9. All right, or else if you are not understanding how am I finding adjoint, you can refer this problem and do the same. Okay, now a21, so it will again be negative, so remove this and this, you get minus 4. Okay, we have a22, so it will be 6, remove this and this, it will be positive, so it's going to be 6. Now the transpose of this will turn out to be 6 minus 4 minus 9, 6. Okay, so this is my adjoint of a. Now let's find what is adjoint of a into b. By the way, b is, let me write b, so matrix b here is 2, 3. Okay, so let's find what is adjoint of a into b. So this turns out to be 6 minus 4 minus 9, 6 into 2, 3. Okay, so let's quickly find this. So you have 6 2s are 12 plus 4 3s are 12, that is we have minus also, so this much, this becomes this much, so minus 18 plus 6 3s are 18. Now this is a 0 matrix, isn't it? Now if this is 0 matrix, if this is equals to 0, this falls under second category. That means system is consistent, okay, and has infinitely many solutions. Okay, now if there are infinitely many solutions, we have to find the solutions as well, isn't it? Okay, so let's see, or let's learn how to find those infinitely many solutions out here. Okay, now here what you need to do is, in such case, if you have infinitely many solutions, what you will do is, from here, see here carefully, you take any element. Okay, so let me take y to be any number k. Okay, now from here, then we get, okay, so from this you get 6x is equals to 2 minus, see here carefully, you get 2 minus 4y, isn't it? So that's 4k, because y is equals to k, isn't it? And from here you get you get 9x is equals to 3 minus 6k, isn't it? 3 this goes over there and becomes minus 6k. Now let's subtract these two. Okay, so when you subtract, you get, minus 3x, so it becomes equals to minus 1 plus 2k, isn't it? That is, we can say x is equals to, first multiply with minus, you get 2k minus 1 minus 2k, and bring this 3 down there. Okay, so that means, see, first you took y equals to k, you substitute it out here, you get 6x equals to 2 minus 4k. Put y equals to k here, from here you get 9x equals to 3 minus 6k. Subtract, you get this much, and from here you get x equals to this much. Okay, so therefore you said it has infinitely many solutions, and those infinitely many solutions are x equals to 1 minus 2k by 3 and y equals to k. Now put any value for k, you get your infinitely many solutions. So this is how we solve sums on consistency and inconsistency. So you may pause the video and note down the solution. Okay, so let's have a look at this particular problem. So question says, first find A inverse. Okay, now all of you know how to find A inverse, right? So again, the formula says A inverse is nothing but 1 by determinant of A into adjoint of A. That's the formula that is available with us. Okay, so let's quickly find A inverse for this particular matrix. Okay, so here we have, first let's find what is determinant of A. So it will be 1 into 3 into minus 4 minus 12, right, minus 3 into 2 is minus 6, so it becomes plus 6, minus 2 into 3 into minus 2 is minus 8, minus 3 into 2 is 6, plus we have minus 3 into 2 into minus 3 is minus 6, minus 3 into 3 is 9. Okay, alright, so let's quickly evaluate this. So we have 1 into anything will be that much itself, and this is minus 6, minus 2, this is minus 14, right? So minus 14 minus 2 is plus, okay, so plus it is 28, right? Alright, now next we have minus, how much is that? This is minus 15, so minus 15, minus into minus is first and foremost plus, okay, so 3 into 15 is 45. Alright, now quickly evaluate this. This will turn out to be exactly 67, which is not equals to 0, right? So that means if this is non-zero, then we get that A inverse exists. And now since we found this part, let's find what is adjoint of A. Okay, so first let's find, adjoint means it contains cofactors. So A11, so minus 1 to the power 1 plus 1. Okay, so what is minor of A11? So A11 is this one, so minus is this part. Okay, so let's see how much is this. So this is 3 into minus 4. 3 into minus 4 is minus 12, minus, see here carefully, so minus 3 into 2 is minus 6, right? Okay, so we got this much. Now let's quickly evaluate this and check. This will be equals to minus 6. Okay, now similarly let's find what is A12. Okay, so A12 is this one, so A12, this means minus 1 to the power 1 plus 2, right? Okay, now 2 into minus 4 is minus 8, minus 3 into 2 is 6. So how much is this? This turns out to be exactly 14, isn't it? Because this is minus 1 only, so this is minus 14, so minus 1 into minus 14 is just 14. So similarly let's find A13. Okay, so we got our cofactors here, so let's find our adjoint, because I need adjoint, right? So therefore, okay, so let me write it here only. So we have adjoint of A. Okay, so adjoint of A is the transpose. First and foremost, remember there is a transpose, and you get A11, that is minus 6, 14, minus 15, A21 17, 5, 9, 13 minus 8 minus 1, and the transpose is, so this minus 6, 17, 13 comes out here, you get 14, 5 minus 8 minus 15, 9 minus 1 as the adjoint of A. Okay, so we got the adjoint here, isn't it? So that's why your inverse, okay, so therefore your A inverse will be, equals to, using this formula, it will be 1 by determinant of A, which is 67, and we have into adjoint of A. Adjoint of A is this much, isn't it? So it's minus 6, 17, 13, 14, 5, minus 8, minus 15, 9, minus 1. So this is my A inverse. So I got my A inverse, right? Now, question is asking me to solve this system of equation, okay? So the given system of equation is this one. That's what you'll write at first, okay? Now, from the given system of equations, okay, from given system of equations, tell me what is A. Now A will be 1, 2, minus 3, 1, 2, minus 3, okay? We have 2, 3, 2, 3, minus 3, minus 4 as A, okay? And all of you know X will be the column matrix containing X, Y, and Z. And what is your matrix B? Your matrix B will be a column matrix containing minus 4, 2, and minus 11. Okay, so these are your matrix, and we have, therefore, X will be equals to A inverse B, isn't it? We know that the solution will be this much. Now let's see how much is this. Now what is A inverse? See, A is this matrix, isn't it? Now isn't this equals to this one? Yes, are they same? Yes. So that's why if I ask you what is the A inverse, that is the inverse of this, it will be nothing but this much. Okay, so in place of A inverse, I am writing 1 by 67 into, so A inverse, that is this matrix, minus 6, 17, 13, 14, 5, minus 8, minus 15, 9, minus 1. Okay, so we got, this is my A inverse. So we have B also. So B is this matrix, minus 4, 2, minus 11. Okay, so next is you need to multiply. Okay, so multiply this matrix with this. Okay, so I'll directly write down your answer. Okay, so when you multiply all these, it will turn out to be, okay, so let me write. So this is minus into minus is 20 plus 24, 17 into 2 is 34, right? Plus 13 into minus 11 becomes, okay, so let's see, this is 11 or minus, just let me check. Okay, so this is not minus 11, this is just 11. Okay, I'm sorry, my mistake here. Question says this is just 11, not minus 11. Okay, so 13 into 11 becomes 143. Okay, similarly multiply this with this, you get minus 56 plus 10 minus 88. Okay, now we have 60 plus 18 minus 11. Okay, now let's quickly evaluate this and check how much is that. 1 by 67 is already there. Okay, now let's add this. 3 plus 4, 7, 7 plus 11, carried over 1, 1, 5, 8 plus 2, 10, carried over 1 gives me 201. Okay, now we have, when simplify this, you get, let's see, so we have minus minus out here, so minus 8 plus 6, 14, carried over 1, so 1 plus is 6, 6 plus 8 is 14, plus we have 10, so it becomes minus 134. Okay, similarly simplify this, this becomes 67 exactly, right? Okay, so we got this thing. Now if you take this 1 by 67 inside, you get 201 by 67. Now when you divide 201 by 67, you get 3. Similarly divide 134 by 67, you get 2. So that's why it becomes minus 2. 67 by 67 is nothing but 1. Okay, so therefore we got, see, matrix X is nothing but X, Y, Z, And if xyz is equals to, that is, this turns out to be 3 minus 2 1, this means that x is 3, y is minus 2, and z is equals to 1. Okay, so this gives me the solution for this particular question. So you may pause the video and note down your solution. Okay, so let's take a similar kind of question. If A is given to be this matrix, find A inverse. Now, as you are quite comfortable with finding A inverse, I have directly written your answer. So determinant of A turns out to be 10, whereas your A inverse turns out to be this particular thing. And after that, you need to solve this system of linear equations. Okay, and this linear equation system can be represented in this way, isn't it? 1 2 1 1 2 1 minus 1 1 1 minus 1 1 1 1 minus 3 1 is written out here, x y z, and 402 comes here. Okay, now if you observe this in earlier question, I took this to be A, right? This was x and this was your B. Now in this case, if you see here carefully, isn't this A transpose, just transpose of this? This is my A now. So if you take the transpose of this, won't you get this thing? Yes, so that's why can I write this as A transpose in place of this. This is my x and this is my B. Okay, now ultimately your aim is to find x, right? So x becomes, if you call this entire thing to be A, then it becomes A inverse B, right? So what is A actually? A is this much. So the value of x can be obtained using this. Now there was one property which said A transpose inverse is equals to A inverse and its transpose. This was the property. So if you use this property, so in place of this, can I write A inverse transpose? Yes. Okay, so B is B itself. All right, now see here carefully, what is A inverse? A inverse is this one, isn't it? So you can take out 1 by 10 outside. Okay, 1 by 10 is kept outside, and you have transpose out here, remember? So we have 4 2 2 minus 5 0 5 1 minus 2 3. Okay, and we have B is 4 0 2. So when you solve this, okay, first and foremost take the transpose. So 4 minus 5 1, okay, 2 0 minus 2 2 0 minus 2 2 5 3 comes out here, right? And we have 4 0 2. Okay, now it's a simple matrix multiplication, isn't it? Now when you finally solve this and get your final answer after multiplication, you are going to get this to be 9 by 5, 2 by 5, and 7 by 5. Okay, that is x is what? X is x y z, isn't it? So x y z turns out to be this much, means what? It means that x is 9 by 5, y is 2 by 5, and z is 7 by 5. Okay, so these are my answers for this particular question. Okay, so with this we close the chapter on determinants. Okay, and in the next class we'll start with a very new topic. Thank you very much.